Oslo through a studentship program between NCOR and NPI and funded by Ministry of Earth Science. And I'm going to talk about glacier mass balance and freshwater flux to Kungsfjord in northwest Svalbard. So this is the map of Svalbard, and if we focus in the northwest part of Svalbard, we end up in Kungsfjord. So this is Kungsfjord, which is open to ocean and surrounded by glaciers in other seaside. So in this image, you can see whatever white you can see is mostly glaciers, and the gray area are non-glaciarized area. So this region, the Kungsfjord basin, is surrounded by glaciers of different shapes, size, and dynamic behavior. So glaciers in the south and southwest side of the fjord are all land terminating glaciers, because that means the terminus of these glaciers are ending on the land, whereas glaciers in north and east side of the fjord are mostly marine terminating glacier or tidewater glacier. That means the terminus of these glaciers are ending into the fjord, and they play significant role, and I will tell you in a while. If we look at the DEM, this is the digital elevation model. The elevation varies from 0 to 1400 meter, and the black outline shows individual glaciers. So there are around 16-17 glaciers are there draining to Kungsfjord, and many of these glaciers are being monitored by different countries. For example, these two glaciers are being monitored by India, and these four glaciers are being monitored by Norwegian Polar Institute. These red dots show the mass balance measurement stakes, which are measured twice in a year, once after the end of winter and once after the end of summer. And this is how a mass balance measurement stakes look like. The total basin area of Kungsfjord is 1440 square kilometer, and here we are interested to calculate the mass balance of all these glaciers, because we know that glaciers are good indicator of climate change, or they are very much vulnerable to the changing climate, and we are interested to know the long-term evolution of mass balance of entire glaciarized area of Kungsfjord basin. So and that is how we want to see that how these glaciers have behaved. These glaciers are behaving with the changing climate. And then most importantly, we are interested to quantify the freshwater flux to the fjord. So this glacier is melting in summer, and some part of this melt water is entering into the fjord in different location, and that is the most important thing. And why? So this is the schematics of glacier ending, tidewater glacier ending into the fjord. In summer, glacier melt in the surface, and some part of melt water enters into crevasse or cracks and reaches bay. And then this water travels underneath the glacier ice and appears at the front underneath the ice, where it mixes with the fjord water. Now glacier meltwater is fresh water, whereas the fjord water is saline, is salt water. When these two mixes with each other, it creates plume. So if you look at the tidewater glacier front in summer, you will see a lot of brown water coming in front of tidewater glaciers, and that is because this glacier fresh water is mixing with the fjord water. And when these plumes are generated, it brings a lot of nutrients from the fjord bottom to the fjord surface, and that makes feeding ground for birds, seals, and other marine animals. And that has been reported in literature in several times. So in short, tidewater glacier front makes a perfect ecosystem. Secondly, the glacier freshwater is mixing with the fjord, and fjords are connected with the ocean. So it is of interest for the oceanographer as well to know the spatial and temporal variability of freshwater input to the fjord, and that led us to do this work. One, investigate the mass balance of entire Kungsfjord basin and quantify freshwater flux into the fjord. Now to do that, to address that, we implement an energy balance model coupled with the snow model to calculate mass balance and runoff. So this is the schematics of a glacier. Glacier ice, on top there are snow. Glacier gain mass through precipitation and driving, and lose mass through runoff. What is runoff? Basically, glacier melt in the surface in summer. Some part of meltwater enters into the meltwater enters into the snowpack, where it refreezes, and then some residual meltwater reaches at the interface between ice and snow, where it is ready to leave that point, and that is what known as runoff, which ultimately ends up into the fjord. So furthermore, we investigated the hydrology of the glacier to quantify the freshwater discharge at the outlet point, where these freshwaters are being added to the fjord. And we use field data like the weather station data, snow depth data, the snow density data, and take measured winter and summer balance data to calibrate our model. And here I show a result of the mass balance. So this is the mass balance. So x-axis is time from 1980 till 2016. Each graph corresponds to each year. This is zero line. The positives are the gain term for glacier, and the negative one is the lose term for glacier. And the white line shows the trend from 1980 till 2016. If we look at the mass balance of entire glacier-rich area, we see the mass balance is positive, but it shows somewhat declining trend from 1980 till 2005. But after 2005, we found little positive trend, and that is because in last 5-10 years, the precipitation in Svalbard has increased significantly, and that is why we found more positive mass balance, a bit positive mass balance in the last 5-10 years. Although the runoff and melt we didn't find any change in runoff and melt. But although we find positive mass balance in this area, but we find wide variability. So here I am going to show mass balance of 3 glaciers in this region. One is this one, BRB, which is in southwest side of the fjord, KNG, which is in east side of the fjord, and ISF, which is in north side of the fjord. And I choose this 3 glaciers because they are in 3 different area of the fjord. And when we look at the mass balance of this 3 glaciers, we see the BRB has always shown negative mass balance, whereas the glacier in the east, KNG, its mass balance is more or less close to 0, whereas the glacier in the north has always shown positive mass balance, which tells that in this area we find wide variability in mass balance, and it varies from south to north and west to east. Furthermore, we are interested to know the freshwater flux to the fjord. So the mass balance model calculates runoff in each location, and then we needed to investigate. And when this runoff is produced here, it takes that water some time to travel to the glacier front. So we also investigated the hydrology and implemented a runoff routing model to route this meltwater to runoff water from here to the glacier outlet point. So that was the main aim. So the main aim of this hydrology investigation was to calculate discharge from the runoff. And in this figure here in the right side, it's the same basin, but different color represent different drainage basins. And each of these drainage basin is pouring water at the fjord in a certain location. And I have shown encircled 5 major locations through which maximum amount of fresh water is being added to the fjord. And these are actually the location where you can see the plume, and these are the location close to where the birds and seal, the marine animals, they forage. When you look at the discharge for 2 months, so I have seen here discharge for 2 months in 2016, July and August. We see this, and different color corresponds to different drainage basins. So I have shown here 5 drainage basins. So we see like these 2 glaciers, Kronerbreen and Kungsveien, they contribute maximum amount of fresh water to the fjord, and that has been evidenced from the satellite image. If you look at the satellite image, you see repeated satellite images show that more amount of brown water coming in front of the glacier. And so with that, I would like to summarize that we used simple energy balance model coupled with snow model to simulate mass balance of entire glacier-rich area of Kungsfjord Basin. We calibrated the model with observational data, and those are automatic weather station data, takes measured data. We find wide variability in mass balance. We investigated the hydrology, and we find that 2 major glaciers in Kungsfjord Basin, Kronerbreen and Kungsveien, they contribute maximum fresh water to the fjord, and that has been evidenced with the satellite data, and also by tracking the seal and the birds. So with that, I'd like to thank you all.